Now, if a sequence is always increasing or decreasing, remember increasing and decreasing, the next term is always getting bigger than the previous term increasing, or the next term is always smaller than the previous term decreasing. AN is increasing or decreasing. Okay. Always go up and always go down. This one is not that way. Okay? It's go up, go down, go up, go down, go up, go down. This is not increasing and not decreasing. If the sequence always increasing or decreasing, we say what? This is called monotonic sequence. Okay. Always increasing and decreasing. The name of it in general, I'm not sure if you see that word or not, but I'll just introduce you for the monotonic sequence. Okay. Okay. So we have this. The sequence is always increasing or decreasing. That's a monotonic sequence. And if it's bounded, if AN is bounded, then it is convergent. Then it is convergent. Make sure that you guys are clear. It's bounded means both bounded above and below. Okay. This is bounded. Okay. We get lazy to say bounded above and below. It's just say bounded. We understand it's like both direction, above and below. So graphically, this is kind of common sense. Let me explain this using graph. Okay. Monotonic sequence means either it's going up and going down, right? If the sequence is going up, but it's bounded above means what? It will not go up forever, okay? It's going up, but keep getting bigger and bigger, but always smaller than something. This is the big M that you have. Then it's convergent to that big M. And same thing, if going down, okay? But it's bounded means what? It's not going to go down forever. It's have some floor right here. It's getting down right here. This is the little M that we're talking about. In both cases, the sequence will always convergent, because if it keep going up, but it's bounded above, then what? It's gonna be lower than the ceiling, so the limit is gonna be less than the big M. Okay, going down, but it's not going down forever. It's bounded below, so the floor is M, so eventually it's going down to some limit that's above the floor. Okay. That is about a sequence. So it's just kind of common sense here. Sequence keep going up, keep increasing. All right. We don't talk about the sequence that keep alternating, go up and down. Keep going up, but never. It's not going up forever. Then it's going to have a limit somewhere in there. Keep going down, but not going down forever. So it's going to have a limit. That's all I say. Let me see if I missed any information on the first section. Guess not. So what we're saying in here. You're talking about sequence. Okay, sequence is a list of numbers. Okay, follow some rules. We have general terms to represent, and we see the way how to write a sequence. And we can add sequences, subtract, multiply, divide sequences. Okay, and it's the sequence. The ending behavior sequence go to a finite number. We say the sequence is convergent. Go to infinity or undefined. We say the sequence is divergent. Okay. And next, I'm going to introduce to you something called series. Okay, series. We are talking about 11.2 series. So first of all, we have a sequence: A1, A2, A3, A4. Right? Now, guess what? We're going to add all the numbers of the sequence together. It's called the sum. Little s equals what? A1 plus A2 plus A3 plus A4 plus forever. Okay, we never stop. And in short, we write this way: the sum of A, N, and run from 1 to infinity. Okay. And and this is called a series. And we have two cases in here, like sequence. If the sum right here is finite, then we say that the series is convergent. The series is convergent. If it's infinity or undefined, then we say that the series is divergent. Okay, so two cases. You have a one that you keep adding forever, but it turned out to be a finite number. Yeah, that's going to happen. I'll show you an example. You see that. You say that the series is going to be a convergent series. Okay, and if you keep adding, and what the final number is going to be infinity, keep getting bigger. Infinity right here, I imply two cases. Could be positive infinity, could be negative infinity. So let me write it this way. Or undefined means what? You cannot find a sum. And you say that the series is divergent. Okay, so let me give you examples on those cases you see. The first simple example that we had before. 2 plus 4 plus 6 plus 8 plus da da da. You see what? Keep adding bigger number, right? And that sum is going to be infinity. This is a divergent series. Now, take a look at this example. 1 plus 1/2 plus 1/4 plus 1/8 plus da da. You know what? This sum is going to be equal to 2. And the geometrical way of saying this, think of number 1 is like a square. A half is like a half of square, okay? 1/4 and 1/8. 1/16. Keep adding. See what? It's equal to 2. Okay. So really, you have a sequence. First, you add all the terms of the sequence. A series, add all the terms of the sequence. Okay. The series is what? Sum of all terms of a sequence. That's the idea. Okay. And this sum is equal to 2. Really, keep adding forever. Keep filling up that little box right here, and eventually you got about 2 squares, and this is convergence. Okay. So in this is the main thing that you guys are going to learn in chapter 11. It's about series, really, because sequence is a term, and you add all the terms, you have a series. And the main question we try to solve is when is the series convergent, when it's going to be divergent, and if it's convergent, can we find a sum? What is that equal to? Sometimes, say many times, you know the series is convergent, yeah, but when you add them up, you don't know what it's equal to. Right? You know it's equal to some number, but we don't know what it is. So many times we learn, we try to figure out that a value of convergent. All right, and that was the main thing for the whole chapter. And in here, I'll just give you some introduction to sequence and series and the terminology of it. Okay, let's start with some simple sequence geometries. How about we talk about series this time? Series, okay. So this is one of the geometry series. We keep multiply by a constant to get next sum, right? 1 here times 1/2, and then times another 1/2. What? 1/2, 1/4, 1/8. So the general term is 1/2 to the n minus 1. Okay. The r is equal to 1/2. The constant that you multiply. Let me write it down in the general term first, because this is an example, right? Say you got a1. The next term is a1 times r, multiply constant. The next term, the third term is a1 times r squared, so forth and so on. First term is 1. You time 1/2, you got the next term. From 1/2 you time the 1/2, you got the next term. Okay. So the general term right here, an is 1/2 to the n minus 1, and r right here is 1/2. You multiply by 1/2. Okay. A general sequence right here. Okay. And then you add them up. A1 plus A1 times R plus A1 times R squared plus da da forever. Okay. And we have 2 cases in here. This is what you can actually think of it like factor out A1. But let me just write it this way so I don't have to. If the R right here is the R stands for common ratio. If R is between -1 and 1 strictly. So R could be -0.9 all the way to positive 0.9, -0.99, positive 0.99. Then the series is convergent. And more than that, the sum is equal to 1 over, what's that, 1 minus R. Okay? And otherwise, if absolute value of R less than or equal to 1, then the series is divergent. Okay? Divergent means what? Either the sum is infinity or you cannot find the sum at all. Okay? So whenever you have geometry series, it means what? This is a sequence, and then you add all the term up, you have a series, right? So add all of them, then you have a series. Okay. And it depends on the R right here. If the common ratio, I think it's gonna time A1. Because factor out the A1 right there. Okay. So what? If you have the common ratio R right here is between -1 and 1, so absolute value less than 1, then the series is going to be convergent. If not, then it's divergent. And I think this is a review because we learned this very carefully when we was in pre-calculus, which is for your information. Okay. And this is the notation for the sum. Many times you cannot find the entire sum, so you can have something called partial sum. You have one partial sum. And what does it mean? You can add like a first couple terms. Say Sn is what? A1 plus A2 plus A3 all the way to An. And this is what? This means what? The sum of the first n term. Okay. Sum of the first n terms. Okay. And in short, this is what? Sum of A, say I run from 1 to n. Okay, so A1, A2, A3, A4, A5. Why do we need that? Because as I say, if you know that the series is convergent, but you don't know the exact sum, so how do you approximate the sum if you don't know the exact sum? And you add up like 1,000 terms, the first 1,000 terms, or first 100 terms, then you have pretty good approximation of the infinite sum. Okay, because the infinite sum may be hard to find. And then you can approximate. And this is called the partial sum. So S2 means what? The sum first two terms. S1 means just the first term. S3 means the first 3 terms. S5 means the first 5 terms. That's just terminology. Okay. And very similar to the sequence that we learned before, we can do map with series as well. Say you have 2 convergent series. Okay. Let's call A is equal to the sum of An, n run from 1 to infinity, and that means what? A1 plus A2 plus forever, right? So the series An right here is convergent to A. And then B is equal to the sum of Bn, n run from 1 to infinity as well. Going to be the same index, okay? This is what? B1 plus B2 plus and guess what? The sum of An plus Bn, where n run from 1 to infinity is going to be equal to A plus B. And similarly, you do a subtraction, you have subtraction. You can't do multiplication and division in here, okay? And if you multiply this whole sum by a constant, the sum of An times C, this means what? C times A1 plus C times A2 plus this is equal to C times A. Only true if the sequence is already convergent. Okay? If it's not convergent, then you may not be able to do that. Let me see if I missed anything. Okay, that will be it for introduction to sequence and series. Let me stop this section, this video clip right here. On the next video clip, I'll show you how to test for some series to see if it's convergent or divergent. Okay, so you have a sequence, you add all of them, you have a series, and then they ask you a question. Do you know if that series is convergent or divergent? I want to show you some tests to see if that series is convergent or divergent. and that's for the next video clip. Thank you for watching. Let me stop right here. If you have any question, please feel free to ask.